Hey guys, welcome to the second session of Cassandra Learning, the series for learning software for the non-technical people. And today we are going to see about we are going to get an introduction to what software is. The last session we got an introduction to what is a computer, right? So we saw that a computer is a programmable electronic device that contains a set of hardware and an essential software called operating system. And it can communicate to the outside world through various devices and various technologies, right? So if you hadn't attended the first session yet, please go back and take a look at the first session and then come back here. If you had liked the first session, please like, share and subscribe. Now let us get into the second session. What are the topics we are going to see? We are going to see what is software, what are the types of software that are available and how are they created. So that is our primary objective of this entire series, right? We are going to create software of our own. So we need to know how are they created firsthand. So we are going to see how are they created, and we are going to understand what a software stack is all about. There is a software stack in a computer. In every computer there will be a software stack that is built upon your hardware. We are going to see about that, and then in that particular stack we are going to take out, or we are going to focus on a specific area of the stack, and that will be our primary interest, right? So interesting, right? So that is what we are going to see today. So let us get into what is a software. We learned that a computer is a programmable device, right? A computer is a programmable device. So obviously there should be a lot of programs running inside a computer, correct? So a software is a general term for all these programs that run on a computer. That's about it. Software is a general term. It is used to represent all programs, all types of programs that run on a computer. So we already know about some of software, but I'll explain you what are the types of programs that we create and for what purposes. Programs are created for various purposes. So the first one being the command and control for the internal hardware, right? We saw something called as an operating system, and we call that a software as well, right? So an operating system is also a software, and this is basically for taking the command and control of the internal hardware platform of a computer. So an operating system is one type of software. The second one is to initialize communication and control a peripheral device. Say for example, you are attaching a printer or a camera to a computer. If you are like a little old, and if you remember how a camera connected to a computer in the early 2000s, so for every camera or a printer they give you a CD, right? So you put that CD in your computer, you install something, and then only the computer will be able to recognize your external device and then talk to it and then take control of it, right? So these kind of software that we install is called a device driver. So a device driver is another type of software. Nowadays what happens is the devices are plug and play. So when you simply plug in your USB cable, automatically the operating system recognizes there is an external device being attached and asks for the device driver identity and looks up for the software on the internet and then automatically installs it. We need not worry about basically installing we need not take the headache of installing the device driver software nowadays. But even now the device driver software is definitely needed for an external device to connect and communicate with a computer, right? So device driver is another type of software. And then there are also softwares that are packaged along with your operating system that creates various security routines and protocols. For example, in Windows you can see an authentication manager, you can see communication protocols like TCP/IP routines. All these communication and security related software routines are also software basically, right? So that is the third category of software that we can recognize. And then the fourth one being the applications. We simply call them apps. In mobile terminology we call them apps, but apps basically is a short form of applications, and applications are created for various purposes. Maybe it can manage a school or a college student database. It can be for attendance. It can be for payroll processing for employees. So many applications are there, or even a simple ticket booking. Everything is a application. All right. Now we'll see what are the types of software that are available. So we have basically we broadly can classify the software into two types. One is the system software and another is an application software. So system software, like I said, are operating systems, device drivers, language processors. Say for example, whatever command you type in a command prompt or somewhere, those commands are basically processed and converted into a machine language, right? So this kind of language processors, they are also system software. Similarly, monitoring systems and interfaces, which basically monitors your hardware, your memory, your CPU, how much of CPU is used, how much of memory is used, all that monitoring, whether it is used efficiently or not, are there any malware that is disrupting the entire operation. Everything is all these software that monitors and creates interface to your hardware systems is all system software. Even your security systems and firewalls, they are all system software. So what is a firewall? Firewall is again a piece of software in an enterprise or in a office kind of environment where you can protect your computer or a series of computers from outside attack, secure from outside unwanted entries, all that to the network. So that is called a firewall. So we will see all that one by one in later sessions in detail. But just these are some system software. And application software, whatever applications that you are using, you might have used a lot of applications in today's world, right? So all these are application software. So broadly classified into two categories, system software and application software. So how are they created? How is a software created? Like I said earlier, a software is basically a set of instructions, and these instructions when supplied to the computer, the computer has to recognize it, right? So the computer should understand it. So these are machine understandable instruction set that are stored as a set of files. So simply we can put it that way. They are a set of files which contains machine understandable instructions to do a specific job, right? So these files, so we need to write these files. So this process is called programming or coding. And mostly softwares that are close to the hardware are written are very low or at a very low level, and they can only understand very fundamental instructions. So low level instructions. So for that we have a specific language called as an assembly language. So which will look like this. The assembly language will look like this. Basically this assembly language, I believe, is to add two values. And an assembly language is then converted by something called as an assembler into a machine language. So do you know what a machine language is? What can a machine understand? What language can a machine understand? A machine can understand only two things in the world, a 0 and a 1. So these are the two things that a machine can understand, nothing other than that. Now whatever has been given here, like begin, pass, move, add, everything has to be converted to this 1 and 0s. So machine only, a computer only understands binary, either it is 1 or 0. So to tell you in a practical sense, what is 1 and 0? Why these two numbers? Why can't it be 5 and 6? Why can't it be 9 or 10? Why 1 and 0? So in electric terms, so a computer is an electronic circuit, right? A computer is an electronic circuit, right? So in this electronic circuit, either can be switched on or switched off. If a particular output is off, it is not going to emit any signal. So that will be considered as 0. If there is a signal, there is some electric pulse on a particular output, then that is considered 1. That's all. It's as simple as that. If you take a multimeter, take a wire, measure it. If the power comes, that is 1. If there is no power, that is 0. These are the two states a computer can understand. So just based on that, we are building complex circuits and algorithms to perform everything else. Amazing, right? So see this. So this assembler is the one. So this is an assembly language. Even this is something which a machine cannot understand, which we cannot understand. It's a RS, RCL, R7SEG. We don't know what it is. Machine even doesn't know what it is. Machine, like I said, can understand only 1 and 0. So only trained people who understands assembly language, they can run this particular, they can write this particular program, and then they run it with the help of an assembler, which then converts everything into 1s and 0s and then feed it to the computer so that the computer can understand it and run the instructions. So this is a low level instruction, low level assembly language, where now in modern world we are not going to program like this. This is going to be, nobody is going to become a computer programmer if this is how we need to program, correct? So now there are a set of high level languages, very sophisticated way of communicating to a computer like a normal English, or even today we have other language compilers too, but I'm not very familiar with that. But say for example, take this on the right side. This is a high level language. It says num1 equal to 5, num2 equal to 10, sum equal to num1 plus num2, which is very similar to what we read in mathematics in our school, right? So this human understandable, normal human being can understand this, and then understand and figure out what this program is trying to do and all that, right? So this is a high level language. Now for this to work, we need something called as a compiler or interpreter. So what this compiler or interpreter does is, it takes this high level language and then convert this into this low level language automatically, so that assembler can convert into a machine language and give it to the machine, right? So these are so nowadays the high level language is a way of programming. So we need not worry about this. Let us leave it to the technicians at Intel or wherever they are working, Motorola or wherever they are working, right? So we will just focus on this particular high level language, because what we are going to do, we are going to create systems and applications using this high level language, and we are going to understand how a high level language code can be written and compiled and run it on a computer, how to run it on a computer. That is our primary objective. All right. So now we have to understand this software stack. We talked about a lot about the machine language, assembly language, and high level language. So how are all these organized on a computer? So how will they work? So if you run a software, what happens is, it's basically in high level language. It is compiled and then it is converted into a low level assembly language, and then again it is converted to the machine language, and machine language can be directly understood by the hardware, and it takes the ones and zeros and processes it. So this is how we layer the software in hierarchy. Now we need not, like I said, we need not worry about machine language. We need not worry about assembly language. We only are going to worry about this high level visual object based languages. This is going to be our primary area of focus as far as this series is concerned. Got it? So let us move on. That is what we are interested in. So what we are going to do in this series, we are going to create application software. We are not going to even bother about creating a system software or anything like that. We are going to create application software for our own use. Say for example, you want to create your own chat application, or you want to create your own payroll processing application. You want to create your own web application for monitoring the attendance of your employees, whatever that is, right? So that is our primary focus. That is going to be, so we are going to develop application software, and then we are going to develop this software using high level languages, which are going to be primarily like an English language or mathematical equations, so which is going to be very simple to understand. If you feel it complex, I am here to make it very simple for you to understand. So don't worry about it. Have a wonderful time here. So in summary, what we had seen in this session is a software generally refers to programs that run on a computer that are broadly classified into system software and application software. System software primarily controls the hardware of a computer, and application software does the user jobs. User jobs, any jobs that user wants a computer to do, we have to do it through an application software. And then these software are primarily instructions provided either in low level or a high level language. So low level language is assembly language, which are converted into machine language by assemblers. High level language is more like English and mathematics. So they are either converted to low level languages by compilers or interpreters. So what is the difference between a compiler and an interpreter? Why are we saying compiler or interpreter? A compiler, there is not much difference. Basically, it converts into low level instructions, but a compiler does it in a program by program way. Like the compiler reads the entire program and then it finds if there are any syntactical, semantical errors in it. If there are, it stops the compilation at the end of after completing the entire, reading the program in its entirety, and then say, these are the errors. Line number 5, this is your error. Line number 7, this is your error. Line number 35, this is your error. So like that. It gives a complete report of error in one go. Whereas interpreter, what it does is it takes one line, converts it, executes it, takes the second line, converts it, executes it. So it's just in time translation to machine language or lower level language. So that is what the interpreters do. Sometimes compiler has some advantage, some disadvantage, interpreters has some advantage, disadvantage. So there are trade-offs and all that. We will discuss that in another session. But compilers, they compile the program in its entirety. Interpreters, they do it and execute it line by line. So what happens when, as far as an interpreter is concerned, when until you encounter a particular line, you will not know there is an error in that line. So half of the execution will be completed, and then when it, say for example, there are 20 lines in a program, the first 15 lines has no errors, the 16th line has error. So the interpreter will run through, execute the 15 lines, and when it hits the 16th line, it will find out there is an error and stop the program then and there. However, a compiler, if in case of compiler, if there are 20 lines, it will read the 20 lines, see if there are syntax semantical errors, and then if there are errors, if there is an error in the 16th line, it will say 16th line there is an error and then stop the compilation. But if there are no errors, it will compile and create a software, executable software for you. So that is the difference between a compiler and interpreter. Alright, I'm not going to go into any of the technical aspects of it. It is all just stories. That's all you need to know for creating a software. Alright. Alright, so we also understood what the software stack is. So the software stack, where on top of hardware we have assembly language, which is a lower level instruction set. And on top of it there is a high level language, which are our programs, which can be of system software or an application software. So our primary focus henceforth will be on learning about application software development using modern high-level languages like Java and Python. Got it? All right. Great, guys. Thank you for being with me. Hope you enjoyed this session. If you like it, please like, share and subscribe. We'll meet in another session tomorrow. Thank you. Bye bye.